Okay, so we're going over section 1.4 homework. So we're going to FOIL this. So we're going to do square root of 3 times the square root of 3 and get 3. And then we'll do the outer. So it's going to be, here's what it's going to look like. Minus 12i square root of 3. And then the inner is minus 12i square root of 3. Terrible 3. And then finally, plus 144i squared. Okay, so what we could do with these middle terms is combine them, right? Because we basically have an I square root of 3. This I square root of 3 is kind of acting like its own variable. And we have negative 12 minus 12, so it's minus 24i square root of 3. And then plus, and we all know what this I squared does. That's really a negative 1. So this just becomes actually negative 144. So the final way I would express this answer, so it's 3 minus 144, so negative 141, and then minus 24i square root of 3. That would be the way I would display that answer in standard form. So whoever asked for 29, is that looking okay to you?
Yeah, that makes sense. Thank you.
Sure. All right, let's try 31. 31's a good one because we have a square root in there, so we're kind of doing the same thing we did in 29, except there's a square root with a negative number. So what I would do before foiling this, I would do this. I would say, well, we know what the square root of negative 16 is. At this point, we should probably immediately say, well, that's actually 4i. And I would make that substitution in there right away, because the square root of 16, like essentially what we did here was just, we knew the square root of 16 was 4, and then we're left with the square root of negative 1, which is your I. All right, now we FOIL, so we're going to get 6, let's see, plus 10i, minus 12i, minus 20i squared. Okay, so we have 6. We're going to have minus 2i, and then we know what the I squared does, negative 1. So then this is actually plus 20. So our final answer will be 26 minus 2i. Notice our final answers always have the real part and then the imaginary part. And they're the two things, if you have those, we call that a complex number. Okay, anything else? Any other questions from the section 1.4 homework? Okay, hearing none, I'll ask one more time, just because we're going to have a quiz on it today. Are there any questions about section 1.3? Because the quiz is on 1.3 and 1.4. So anything else outstanding on solving quadratic equations? Everyone's okay?
Can we go over 43?
This is 43 in 1.3? Sure.
Yeah.
All right. I'm going to put it right in the same section here. So this is from section 1.3, number 43. All right. Here's what we have. We have x squared minus 3x minus 1 equals 0. I'm actually glad somebody asked to do one of these, because this is a completing the square problem. All right, they're probably just because they have a lot of steps in order to get to the final answer. So I think it's good that I'm going over one of these today. Okay, so what we're going to do is we're going to isolate the x variables on one side of the equation. So I'm just going to put this 1 over here as a positive 1. Now I have to determine what, well, actually, again, I made this mistake the other day. The first thing I want to make sure is that this coefficient is 1. And it is. It's already 1. If it wasn't 1, I would divide the entire equation by that value. But we don't have to worry about that here. So we determined the b value. It's 3. Now really it's negative 3, but we're going to end up squaring this value anyway. So it doesn't so much matter if we keep the negative sign or not. Then we want to find b divided by 2. All right, well, that's just going to be 3 halves. Oh, nope, 3 halves. Right? 3 divided by 2. And then we're going to square that b over 2 term. So we're just taking 3 divided by 2 and squaring it. And we get 9/4. So that's the magic number here. We're going to add 9/4 to both sides of the equation. Now, by doing this process, what that allows the left side to look like is a perfect square. You could take the square root of x squared and get x, and you could take the square root of 9/4 and get 3/2. All right? And then whatever this sign is, so it happens to be negative, that's what's going to go in here. And then we're squaring it. So there's our perfect square. Now on the right-hand side, you just have to do a little fraction math. So we know for 1 is 4 over 4 if we wanted to change it to fourths. So it's 4 over 4 plus 9 over 4, so that gets us 13 over 4. Once you get to this step, now the problem becomes the square root method. If you see a big binomial, square it on one side, and then you can put a number on the other side, go ahead and do the square root method. That's going to be the easiest way. So I'm going to square root everything here. I'm going to get x minus 3/2 equals plus or minus. I'm going to take the square root of this. So the top, I can't take the square root of 13, so that stays. But I can take the square root of 4. That's a 2. So when I move this to the other side, I'm going to do this in 2 steps just so you see what I'm doing. All right. So you could leave the answer like that, but if we wanted to make it look even nicer, because the denominators are the same, so we have x is 3 plus or minus square root of 13 over 2, and I'm not expecting you to evaluate that. So I would want you to leave the final answer as that. All right, so I think that was a great example to go over because we got completing the square and square root method out of the way. And then the only other 2 methods for solving quadratic equations would be factoring, and I think at this point we're all, fairly good at doing that. And then the other is the quadratic formula, which is just plug in, the a, the b, and the c value in. So if we did this exact same we could do this. Actually, this will be a good exercise. I'm going to solve this equation, the same one. Let's make sure I'm right. Oh, it's -1. I'm going to solve this same equation, but doing the quadratic formula. And remember, I'm not expecting you to remember it. When I was an engineer for Lockheed Martin and we were trying to figure something out, you forgot an equation, well, you go to your library, figure out, the library we had at Lockheed, and figured out what we needed to do, found the equation, and applied it. And all of you, I don't believe any of you are actually math majors or science majors. Maybe that's incorrect, but you're mostly just going to be applying things. And if you're just doing that, there's not necessary to memorize. So you're going to get this exact same thing on the quiz. So let's go ahead and do it. So we have a equals 1 in this case, right? The coefficient next to x squared. B is -3, and c is -1. So let's do it. See if we get the same answer as this. So x equals, so negative b is going to change that -3 to a 3, which is good, because that's what's there. Plus or minus the square root of, so b squared, well, I can automatically say that's going to be 9. Minus 4 times a times c. So 4 times a is 4 times 1 is 4, times -1 is -4. So 9 minus a -4, all over 2 times 1. So we get 3 plus or minus the square root of 13 over 2. So hey, look at that. We matched the answer. Now, you might be asking yourself, well, completing the square was a much more complicated method. Well, it is. But in certain cases, it's simpler. It just happened to be that for this particular equation, it was easier to do it with the quadratic formula. Now, on this specific quiz today, because I'm quizzing you on making sure you know all of the methods, I dictate which method you have to do for any specific question. But when this comes to, when we have this on an exam, I won't tell you which method to use. So you could choose whatever method you want. And just, I'll reiterate it again, This guy right here works on every single quadratic equation. Okay, anything else on section 1.3? Great. All right, hearing none, we'll call that section 1.3 and section 1.4 have been completed. And we're going to go ahead back to section 1.5. There's just some people who came in late because they didn't know it was virtual, so I'm giving everyone the benefit of the doubt. I just want to just check one more time, so give me a second. Okay. Is Angelo here? No, Angelo. How about Terrence? No, Terrence. Brendan Smellman, are you here?
Yeah, I'm here.
Oh, there you go. Perfect. Excellent. Okay, great. Okay, so we're over to section 1.5. By the way, I actually do have one student in here, so it's not completely ridiculous, but I'm in this giant room, and it is bizarre talking to almost nobody. It's very strange feeling. Very strange times we're living in. Sorry. Okay. Section 1.5. So this was sort of like wrapping up any other types of polynomial equations that are sort of like I'll maybe call them the misfits. You know, they don't really fit into any nice category. They're just what they are. And it's like, okay, we'll just have a section dealing with those. So the first type we went over were higher order polynomials. And essentially, you just have to factor the heck out of them. You factor them, boom, and check to make sure that whatever degree the polynomial is. So for example, in this one, we had degree 3. We should probably expect 3 answers, and we do, -2 plus or minus 1, we're all set. All right, so they're really not too difficult. Then we had rational expressions. These weren't super difficult either, and I'm going to do another example of this today, but it's really just getting rid of the fractions and solving the resulting equation. And then we had these guys where we have square roots, and it's unclear how many solutions we're going to have. So what we have to do is check each solution to make sure that it actually solves the equation. And I believe that's where we left off. All right, so the first thing we'll do, let's do another rational expression equation. So and again, these are ones where you have variables in the denominator. So here's another one. I'm going to change the color here. So we're going to have 1 over x plus 2 over x plus 1 plus 3 over x plus 2 equals 0. Okay, so we want to find some expression to multiply this equation by to get rid of the fraction. So I told you the easiest way was just to take the denominators, so x times x plus 1 times x plus 2. So you just all mishmash them together. Now, sometimes, like in the example we did the other day, where is it? Right here. We did that mishmashing, right? But this was not the least common denominator. But it didn't matter. We still got the same answers, okay? It turns out in the example I'm doing right now, this is the least common denominator. So this is actually the best one we're going to do in terms of not having some extraneous variables. So here we go. We're going to multiply this entire thing. So this first term is x times x plus 1 times x plus 2 all over x. So just give me about 15 minutes to write this one out. Sorry, it won't take that long. These aren't particularly hard. It's just writing the darn things out is kind of a pain sometimes. So what you're going to see is that things can cancel out. In the first term, the x's go away there. Here we have the x plus 1's going away. And then here we have the x plus 2's. Okay? Now, instead of me rewriting this whole thing again, you're seeing that all the denominators are 1. And whatever's left in the numerator is just now my equation. So I'm going to go ahead and FOIL this out, because we have x plus 1 times x plus 2. So that's x squared plus 3x plus 2. And then this middle one is just 2x times x plus 2. So that's plus 2x squared plus 4x. And then this last one is just 3x times x plus 1. Oh my God. I'm in the room and there's only a couple of us and all the lights went out, so that's nice. And then simultaneously my son is telling me, and this could be of interest to folks, the Steelers-Titans football game, which was postponed, is now going to be on Monday night. So any fantasy football fans out there, plan accordingly. Anyway, Anthony, could you go over there and hit the light switch? Would that be possible? It's right on the wall by the door. After this class, I think I'm just going to go home and hibernate because it's been a weird couple hours so far. So, all right, what do we do now? We're going to combine like terms. So all the x squareds, we have x squared plus 2x squared plus 3x squared. That's going to be a 6x squared. And then all the x's, we have 3x, 4x, and 3x. So that's 10x. Am I doing that right? Yep. And then finally 2. Yeah, 2. 2's the only variable by itself. So then, look, we get this equation, and it comes down to be a quadratic. Somebody tell me, what would you do in this case? What's the first step? Like if you saw
Divide
this.
out 2.
Yeah, you gotta this is the first step actually in any quadratic. If you see a GCF, a greatest common factor, get that sucker out of there. So we take a 2 out, and we're left with 3x squared plus 5x plus 1 equals 0. Okay, so when I look at this, this is the thing now we have to solve. I'm seeing, you know what? The numbers are small, which means if I did the quadratic formula, it's not going to be terrible. I don't think I definitely can't factor this. And if I'm going to do the quadratic formula, I might as well not complete the square, and I can't do the square root method. So what I'm going to do is I'm going to do the quadratic formula. So A is 3, B is 5, C is 1. And let's see what we get. So x equals, so negative b, so negative 5 plus or minus the square root. B squared is going to be 25. And then 4 times a times c is 12, right? It's 4 times 3 times 1, all over 2 times 3. So we have negative 5 plus or minus, oh, that's 13 again, all over 6. Well, there you go. That was pretty quick. Nothing to cancel out there. There's your final answer. Okay? So just to repeat the process, multiply the denominators together. That's the term you multiply the entire equation by. Cancel some stuff out. This gives you an equation with no fractions. Combine like terms and then solve whatever equation is the result. And always look for that GCF. Okay? All right, so I'm only going to give you those 2 rational expressions, and the homework won't, really be super complicated. All right, the next type, I'm going to do probably just one more example of one of those square root examples. All right, so let's say you had the square root of 6x plus 4 plus 2, that's outside the square root, equals x. Okay, so the first step in these problems is to isolate the square root. So I'm going to put the square root of 6x plus 4 by itself, and then just move the 2 by subtracting 2 from both sides. Now I need to remove the square root, so I'm going to square both sides. So when I square the square root, I just get the radicand. But now over here, I have to worry about squaring this binomial, but it's a pretty simple one. X squared minus 4x plus 4. And then you combine like terms. let's see, I'm bringing over a negative 6x, so negative 10x. And then, oh, is that one really that easy? It is. The 4's cancel, and we're left with that. Now it's a two-termer. We know we could factor out an x, and we get x minus 10. So that's showing us that the two solutions are x equals 0 or x minus 10 is equal to 0, so that another solution for x is 10. Now, because we took a square root, we don't have a plus or minus thing going on here. We have to check to see if one of these answers is not a solution. Okay? Okay, so let's try to look at 0. So you just plug the x value into the original equation. So if I do that, I'm going to get the square root of 0 plus 4 plus 2 equals 0. So the square root of 4 is 2 plus 2 equals 0. So can 2 plus 2 ever equal 0? No, it can't. So that means x equals 0 is not a solution. Now we'll check the other one. Square root of 6 times 10 is 60, plus 4 plus 8, or plus 2, equals 10. Well, the square root of 64 is 8, plus 2 equals 10. Well, hey, that's true. So that does mean x equals 10 is the solution to this equation. They don't seem terrible, right? They're pretty reasonable. Yeah? Any questions on those? Anything that any step in there that somebody might have a question about before I show you the last type of equation in this section? Seeing none, I shall show you the last type. Okay, so these are equations with rational exponents. Now, there's only a few cases where some of you will actually need to do these. So I'm only going to give you a couple examples, and they're the simpler ones. And then I'm going to assign homework problems that are actually very similar to these as well. So let's just start with, we'll call this example 1. I'm only going to do 3 of them because they're actually pretty quick. What if you saw this? X raised to the 3/2, that's your rational exponent, the 3/2 there, equals 27. Okay? Now remember, our goal is to always find the value of x. So what we want to be able to do is try to isolate x. Can anyone tell me how might I go about doing that here? How might I go about eliminating x?
Couldn't you do the third root of x?
So go ahead.
I think in the p section.
You can transform it into a square root, right?
Yeah.
So if I did that, here's what I would get. I would get x cubed under a square root, right? And then if I simplified that, I'd get x times the square root of x. And I'm stuck again, right? That would be, you could actually do it that way, but that's a lot of steps. But can you do this? Like if I had x equals 4, can I square both sides of that equation? Right? I could square both sides and get x squared equals 16, right? And that's still valid. So with that being said is you can raise all the terms. Well, you can raise the left side of the equation to an exponent and raise the right side of the equation to the same exponent, and it doesn't actually change the fact that the equation is true. So here's how you would do this. What I would do here with x to the 3/2, if I wanted to neutralize the 3/2 exponent just to get x by itself, I would raise it to the reciprocal exponent. Now I'm going to do this in steps. So if I raise that to the 2/3, I have to raise 27 to the 2/3. But watch what happens over here. What's the rule for raising an exponent to the exponent? Do you add them or do you multiply them? Just yell it out. What's the rule?
Multiply.
Yeah, you multiply. If I had x squared raised to the squared, that'd be x to the 4th. So when I multiply these 3/2 times 2/3, I get 6 over 6, which is 1. So really, it's just x. So by raising that rational exponent to its reciprocal, I get rid of the exponent over there. But now I have to deal with the 27, which is now a third root of 27 squared. So here's the easiest way to solve this. Since you can break up roots, right? That's the same as the cube root of 27 squared. And do we know the cube root of 27? What value is that?
3.
Yeah, 3. So it'll be 3 times 3, or 9. So x equals 9 is the solution to that equation. Good. That wasn't too bad. All right, let's try another one. Example 2. And really, they're not going to get any more complicated than this. Now I'll give you an expression, right, instead of just the variable x. But the process is the same. You're going to see either x by itself raised to some rational exponent, or you're going to see some binomial or some polynomial raised to the rational exponent. But the next step is the same. You're then going to raise, again, and I'm just going to do this so you see the process in the notes. I'm going to raise that whole thing to the 3/2 power. And then that means the 4 has to be raised to the 3/2 power. So by doing this, I eliminate the fact that 3x minus 1, that binomial, has any exponent. So now I just left with 3x minus 1 equals 4 to the 3 divided by 2. So we can change that into the, so we know it's going to be a square root because 2 is on the bottom. So square root of 4 cubed. Okay, so here's what we could do. 3x minus 1. And again, the easiest way you know how to do these, the better. Now, 4 cubed, what is that? You could just, this one's an easy one. So 4 times 4 is 16 times 4. So that's 64. And we all know what the square root of 64 is. It's 8. So 3x equals, move that 1 over, you get 9. And then x equals 3. Boom. There you go. One more. Now this one is going to look just like the previous one, but there's going to be some slight, the answer is going to look funky. All right. All right, so what do we do here? Well, unlike this second problem, I had already isolated the binomial with the rational exponent. So that's what you're going to want to do. Isolate the binomial with the rational exponent. So 9 minus 7 gives us a 2. All right, now we're going to do that same thing where I'm going to raise both sides to 3/4, right? So now my next line becomes 2x plus 1 equals 2 to the 3/4. Now this sucks because the denominator is 4, which means it's a 4th root. But we know how to work with these for now, okay? So let's see what we could do. So we have 2x plus 1 equals, so what is this going to look like? It's going to look like the 4th root of 2/3. Okay? In other words, that's the 4th root of 8. All right, because 2 to the 3rd power is 8. So here's the thing. You can't take the 4th root of 8. There's nothing you could do, right? When you do like 1 raised to the 4th power, you get 1. 2 raised to the 4th power, what's that? 16, right? So we actually can't break this radical down anymore. So you just have to leave it as that ugly looking 4th root of 8 and then solve for x. So we have 2x, moving this 1 over. And then divide everything by 2. So you have the ugly looking solution to this is the 4th root of 8 minus 1 over 2. So I wanted you to see that just in case, you know, one of the homework problems didn't, you know, look similar. Like they're all not always going to be whole numbers. Okay? But that's all I wanted to show you for rational expression. So are there any questions on that? Cool. Okay, seeing none, I have about 10 minutes before I wanted to give you that quiz, because I wanted to give you about a half hour. So all I'm going to do is introduce section 1.6. But before I do that, I'm going to give you the homework assignment for 1.5, and it's not a lot. And what we'll do is I'll ask you to submit this on Tuesday to get more bonus points for the upcoming exam, which I'm not entirely sure of the date, but I'll know by next Tuesday. So here's your homework for section 1.5. I will post the pictures of it once I get back to my office. There's not a lot. We're going to say it's 9, 17, 19 to 25, 37 to 45, and then 59 and 61. And again, these are odd. So you're not looking at a whole heck of a lot. And basically, the first two are factoring. This middle bunch are the rational expressions, and then the square root problems, and then 59 and 61 are the rational exponents. So this is going to be submit to Dropbox by next class. Okie doke? Super.
What
Excellent.
page is this on?
Oh, I'm sorry. This is on page... And I'll just point out, there are some other weird types of equations in this section that you're not responsible for. It's only the ones we went over. This is on pages 140 and 141. And again, I'll take those pictures and post them to the D2L site. All right, so let me give you just a quick little intro. If I can find all my papers here. All right. This will be very brief. Okay, the next section, section 1.6, is on inequalities. Again, I'm hoping some of this is a review, because you've definitely talked about inequalities before, but there's some things in this section, and I'll be honest, if anyone has to take Math 107, or you're taking economics at some point, there are some things in this section that will actually be vitally important to understand at least what we're trying to accomplish. So let me just give you a very brief intro to this section. We'll maybe do one problem or something. All right, so just let's review the symbols. Okay? You've all seen these before, like greater than. Right, this is greater than. We have greater than equal to. Less than. And then less than or equal. I probably didn't even need to write that out because everyone should be aware of those. But now, something you may not have done, most of you probably have, would be solving what we call inequalities. And these are actually very simple because the rules are almost identical to solving equations. Okay, so I'm going to give you, there's two rules for solving these. And I'll write out an example inequality first. Something like 7x minus 11 less than 2 times x minus 3. I mean, if you remove that less than symbol and put an equal sign, we would easily know how to solve this equation. So here are the rules. Rule 1. For, and this is for addition or subtraction. You'll like this rule. So if you're adding one number, like this negative 11, if you're bringing that over to the other side of the inequality symbol, it's the exact same thing as a regular equation. So same as a regular equation. So nothing's different with addition or subtraction. Rule 2. This is for multiplying or divide. Okay, rule 2. If you multiply or divide a negative number, the symbol, and I'm going to put this in quotes, flips, changes to its opposite. And I'll write a little silly example here. If you have negative 2x, let's say less than 6, all right? And again, the goal of the inequality is to isolate x. So you and then give the solution to the inequality. So here, I have to divide by negative 2. So here's where rule 2 applies. When I do that division, this less than becomes a greater than. That's what I mean by flip. It just changes the inequality to its opposite. So then this answer would be x is greater than negative 3. All right, so multiplying or dividing by negative numbers, and you'll be dividing for the most part, flips that sign. So let's go ahead and use those rules and solve this inequality. So here we go. First thing I'll do is distribute the 2 times x, or it'll be 2x minus 6, okay? Now, this is a good thing to point out. I did 2 times negative 3, okay? But it's only when, this multiply for rule 2 is only when I'm doing it to the entire equation, and it rarely happens. I'm not even sure we're going to even ever see an example where we're multiplying the entire thing by a negative number. But for this one, nothing changes. We just distribute that out. Now, we start moving things around. Now, what I like to do is I like to avoid having to flip that sign just because it's one less thing I got to worry about. So I'm gonna leave this less than, and I'm gonna subtract 2x from both sides and get 5x over here, because then I'm not gonna have a negative coefficient on the x. If I subtracted 7x on the right side, I'd have a negative 5x, and again, I don't want to get into flipping the signs. And then I bring positive 11 over with the negative 6, and I get a 5. So the final line here, isolating x is less than 1. Okay. So how on earth do we express this as a final answer? So x is less than 1. That really is one way to do it. Another way would be to use a number line. Now, I won't make you be crazy with the number line, but I always like to see where 0 is. And then I'm going to mark 1, right? Because that's the place of interest. So when you're using number lines, and we have to know if we're including 1 or not. We're not including 1. So for not including, right, we're going to use a parenthesis in the direction of where all the x values are, and then just shade in the number line. So that's one way to do it. So you see that it goes all the way to, negative infinity. Now, the mathematically proper way to do this would be to use interval notation. So that's why I introduced that previously. So this in interval notation would be negative infinity, comma, 1, and then parenthesis. All right. Well, now what I'm going to do up here is do this. For the number line, and this will be the last thing we'll do. We'll do the quiz next. So for number line, oh, there goes the lights again. Now for greater than, right, you're going to use parentheses. For less than, you're going to use parentheses. But for greater than or equal to's or less than or equal to's, you're going to use brackets. Okay? So that's how we're going to differentiate between less than and less than or equal to, and then greater than or greater than equal to. All right? All right, so we solved our first inequality. Awesome. Okay, so that actually ends our content part of the class today. all you virtual folks have to stay on because during the quiz, you're going to have to have your screens turned on. Okay? So hold on one second. I have to get the email ready to send the quiz out. And you're beginning in a half hour. So same thing as we did last Thursday. You're going to, just like you submit homework, just email me the quiz instead of putting it in a Dropbox. And then I'll confirm I received the quiz from you before you leave the Zoom.